Today we are going to look at equivalent fractions. So we know that fractions are pieces of wholes. We know that they have a numerator and a denominator. Our denominator tells us how many total pieces there are in a whole. The numerator tells us how many we have to work with. And when we look at the word equivalent, it kind of sounds like the word equal. And it's supposed to. That's your clue. So equivalent fractions are where we are looking for equal pieces of fractions. We're looking for fractions that show equal amounts. So we can look at those a couple of different ways. I think, and we'll talk more about this as we go through the lessons, some people like to draw models to see if fractions are equivalent. That is not my favorite way, because sometimes fractions get super close together and none of us are perfect, so none of us can just look at a model we draw and perfectly divide it into equal pieces for fractions. So I think when we draw models, we sometimes set ourselves up to have the ability to make some errors that we don't mean to. We just, when we're dealing with fractions that are super close together, sometimes they might look equivalent on a model when really they're not. So you are going to have a lesson looking at models, but they'll be computer-generated models, so we know that they are perfect. So if we look at this fraction, this is, our denominator here is 1, 2, 3, 4. We have 4 pieces. Our denominator here is 1, 2, 3, 4, 5, 6, 7, 8. So we know that there are different total numbers of pieces in each of these wholes, but if we look at it, they're shaded, the same amount of each whole is shaded. So here we have 1, 2, 3 is my numerator. Here I have 1, 2, 3, 4, 5, 6 is my numerator. So we can see by looking at these models that 3/4 is equivalent to 6/8. That is a set of equivalent fractions. So we have models, and models have their place sometimes, but my favorite method for comparing fractions is the butterfly method. You might have done this in 3rd grade where we went to NTI at the end of last year. It might be something you didn't get, so I'm going to show it to you. So let's start up here. We have 2/5 and we have 4/10. When we butterfly fractions, I take my pencil, my pen, whatever I'm doing, and I draw what looks like a butterfly. So there's my butterfly. Now I need to multiply. You multiply where I've drawn from the numerator of one fraction to the denominator of another, and then vice versa. So we have 2, and you can even put your little multiply there if you want, 2 times 10. I know 2 times 10 is 20. So I'm going to put that 20 above my numerator. So when I multiply this numerator out, my product goes up top. So now this numerator, 4 times 5, is also 20. So after I've butterflied, when I see that on both sides 20 and 20, I know those are equal because they're the same number. So those are equivalent fractions. Doesn't always happen that they're equivalent though. If we come down here to 1/3 and 4/6, I'm going to draw my butterfly. 1 times 6 is 6. 4 times 3 is 12. Well, when I look at 6 and 12, I know that they are not the same number. So there's no way this fraction can be equivalent, but I can go ahead and compare it. What's bigger, 6 or 12? We know 12 is bigger. So you're going to want to draw your alligator. You can even give him some teeth. He's facing our bigger fraction, our bigger number. So when we would read this one, we would say 1/3 is less than 4/6. That's something you'll do in like a week. That's just a little preview of it. So butterfly shows us 20 and 20. They're the same. That's equivalent. It also shows us if they're not equivalent. 6 and 12 are not the same. When I come down here, I'm going to draw my butterfly. So I have 3 times 21. Well, I don't know that right off the top of my head. So I'm going to write my multiplication out. 3 times 1 is 3. 3 times 2 is 6. So 21 times 3 is 63. On this side, I have 9 times 7, which I know is 63. I have 63 and 63. They're the same number, so those fractions are equivalent. The last one we'll look at. I'm going to draw my butterfly. 12 times 4. I should know that. 12 times 4 is 48. That's one of my multiplication facts I should know. Then I have 3 times 16. Well, I don't know that one off the top of my head. I know 3 times 6 is 18. My 1's going to come up here. 3 times 1 is 3, plus 1 is 4. So 3 times 16 is 48. 48 right here, 48 right here. So those are equivalent fractions. So equivalent fractions represent the same amount of a whole even if their numerators and denominators are different. You can use models, but models are not our best. We should butterfly when we can, because that way we know. We know multiplication is going to be exact. We don't know that we can always draw to separate wholes into fractions exactly perfect.